Well, hello everyone. Welcome to Math 10, day number 5. Day 5. Hope you are working through the earlier homework and preparing to hand it in. For today, we're going to start with some warm-up questions. And once those are finished, you can have a chance to look at the solutions here. I'll write them out for you. And then we'll continue on to the next topic related to exponents again. So to get started, here are the warm-up questions for you. There are 1, 2, 3, 4 of them. Just to help you get started, what I'm going to point out is that question 1 has to do with actually working with fractions. So this goes back in time quite a bit, maybe a couple of grades. But often this topic needs some help. So we're just going to dust it off. Just make sure we got this skill remembered. But to help you out, the word sum, whenever you see that, it means you add things together. Sum is the answer from adding things up. Difference. This is the answer that you get from subtracting things from one another. Difference is from subtracting. For C part, the product, that involves multiplying or timesing. Multiplying, times. Okay, so the product is the answer from multiplying terms together. Quotient, that is the answer, as you guessed it, from dividing. Okay, the answer from dividing. Now I'm looking at this question. I gave 2 fractions there, 3/2 and 5/9. So how I'd like you to do each question is just like this. For the sum, that means 3/2 plus 5/9. That's how I'd like you to work on that one. For the subtraction, you see the order matters. And so I'd like you to work on it like this. Subtract that one from that one. For multiplying, the order doesn't matter actually. But I'll say just do it like this, times 5/9. And then quotient, yeah, the order matters. So we'll keep the 3/2 first for this these warm-up questions. Okay, so that should help you with number 1. With number 2, that's kind of like what we did yesterday. So if you need to go back in time, take a look at your notes there. Go right ahead. For number 3 and 4, I'm going to show you this because these are some words that you might need. Improper fraction. This is when you have a big number on the top and a small number on the bottom. See the big one's there and the small one there. That's an improper fraction. A mixed number, that's when you have the number written as 2 parts. Just like 5.5. This is a mixed number. So it's like the main part and then the little fraction piece. And what you have to be able to do is change from one type to the other. And that's what questions number 3 and 4 ask you to do. All right, so you can pause the video, take the time you need in order to complete these 1, 2, 3, 4 questions, and resume the video when you are ready. And I'll provide the solutions here as usual for you. All right, see you shortly. Have fun when you do it. Bye-bye. Well, hello. Welcome back. Let's take a look at these, each of these questions here. Work through them for you so we can complete the warm-up section. The first part is to add these two fractions together. So as I was saying, when you're adding, that's talking about the sum. So that is 3 over 2 plus 5 over 9. Now, what has to happen when you're adding fractions is you need a common denominator. That is, the bottom parts have to be the same. And so here's what you do. What you do is you take the first fraction and you multiply the top and the bottom by the denominator of the other fraction. So you see the 9 is there, so it goes there and there with the first fraction. And you do the same trick with the other fraction. The other fraction is 5 over 9, and you multiply it by the other denominator, which is the 2, top and bottom. So doing this kind of jumps ahead. We were doing product afterwards, but when you're multiplying fractions, you do top times the top, bottom times the bottom. Top times the top, bottom times the bottom. So the top here, 3 times 9, that gives a 27. The bottom is 2 times 9, that gives 18. Here we have 5 times 2 for the top, so that's a 10 over 18 like that. And now the trick is, or the key is, because the bottoms are now the same, now you are allowed, now you are able to add the tops together. Okay, so adding the tops together, 27 plus 10, that gives 37. And that will be over the denominator that you see in both those places, 18 only, okay? You add the top, you combine the tops together, but the denominator, the bottom, it stays the same as 18. And that creates the final answer, the combined answer, the sum for those two fractions there. Let's take a look at the difference now. With the difference, you also need a common denominator. So we have to do the same, I don't want to call it a trick, same strategy, technique as with adding, as with the sum. So this denominator, the first one has a 2, but it needs the 9. So we give it the 9. Top and the bottom. This denominator, it needs the 2. And so we make that happen. Top and the bottom, always multiplying like that. And now, as I said, a little out of order. Multiplying comes in the next question. We have it here now. So we go 3 times 9, top times the top, it's 27. Bottom times the bottom, 2 times 9 is 18. Okay, now, go to the next fraction, same thing. Top is 5 times 2, which is 10. And then the bottom, which is 9 times 2, that's 18 like that. So now, because the bottoms are the same, now we can work these two fractions together. And so 27 minus 10, that's a 17. And remember the denominator, it stays as it is. 18 there, 18 there. 18 there. Finished. So let's go on to the next couple now. The product. As I said, maybe this one should have been first because we actually used multiplying for the earlier answers. But because we didn't, this should now be easy. So with multiplying, as I was saying in the earlier question, you go top times the top, bottom times the bottom. And so now when you do that, watch what you get. Top times the top is 15. And the bottom times the bottom is 18. Now, this might look like you're finished, but in fact, what you always want to do is reduce the fraction so that if there's a number that divides into both of these numbers here, a number that divides into both the numerator, the top, and divides into the denominator, the bottom, well, then you do that just to get the numbers smaller. Now I know, and I think you might know too, that there is a number that divides into both of those, namely the number 3. So you divide both the top and bottom now by 3 in order to get these numbers smaller. So 15 divided by 3, that gives you a number 5. And now 18 divided by 3, what does that give? That gives a number of 6. And you see, the numbers are smaller like we wanted. There's also one more thing to check. Can they be divided any further? Is there still another number that goes into both of those? Oh, and 1 doesn't count. Well, the answer is no. So that's it. This is as small as these numbers can get compared to one another. So that'll be the final answer for multiplying. But I want to make your life comfortable. And I want to point out that when you start multiplying numbers together, they can get pretty big. 15 is not so bad, but 15,265 might be a bit of a struggle. So what you want to do is even before you start multiplying, what you're allowed to do is start doing some simplifying. And so watch this. It says simplify first. You see, we're doing the top times the top. And so you can write it as one fraction like that without working it out. Okay, that's the key. Save your mental energy for later problems. And on the bottom, we got 2 times 9. And so you see, this is all one fraction now. And the benefit of this is to divide whatever numbers you can in order to get the numbers small to begin with. So is there a number that can divide into a number on the top as well as a number on the bottom? Yes, there is. Okay, you can divide by 3. 3 divides by 3, which is on the top. 9 divides by 3, which is on the bottom. See? Same number divides the top and divides the bottom. So you do that. What's 3 divided by 3? 1. You're left with times 5. What's 9 divided by 3? 3. So you're left with the 9 changes into the 3 now. But you still have the 2 in front there. See, so dividing first makes the number smaller, and you get to the same answer anyways. Because what's 1 times 5? 5. What's 2 times 3? 6. Success. All right, so that was a nice question for finding the product of fractions, multiplying. Last is dividing. Quotient is with dividing. And as I asked, was to do it in this order because it matters. 3 over 2 divided by 5 over 9. Now, what you always want to do is you want to do two things at once in order to help solve this type of question. And I'm going to add that it even works when there are letters like X's and Y's and all that involved. Okay, that'll be important for later. What you do is you always change the dividing sign to multiply, and at the same time, turn the second fraction upside down. Times upside down. So 3 over 2 changes to times the second fraction, okay, times upside down. That's how you can deal with dividing. Now, because we have the fractions multiplied together, well, we know how to multiply. We did that earlier on. Okay. A thing to watch for is to simplify. So watch. Could do this extra step that just shows everything is one fraction. But with multiplying, we don't actually have to. We can just work from this point here. And see, is there a number that divides both on the top and on the bottom? Is there a number that divides 3 and 2? Nope. 3 and 5? Nope. 9 and 2? Nope. 9 and 5? Nope. Okay, so no simplifying in this situation. Okay, no canceling out to make the numbers smaller ahead of time. We're stuck with these. We got to work with them. But as you can see, they're not so bad. 3 times 9, boom, 27. 2 times 5, 10. Done. Okay, so hopefully that was a nice warm-up with fractions. We're going to be needing them for this topic here. A reminder from last day, this question number 2. The first thing I would do is I would simplify the inside. And what that happens just makes it a little nicer and easier to work with. So I see there's a 3 on the top and a 6 on the bottom. And this is exactly what I was just talking about with the fractions we just did. You got x5, x6, like that. That's a y2. And on the outside, don't forget the outside, -3. But see, you look at these numbers, 3 and 6, looking at the inside first. Is there a number that divides both 3 and 6? Well, yes, there is. Simply the number 3 again. Seems to come up a lot. It's just the way I was thinking. Okay, but you can divide both these numbers 3. Work on these first. 3 divided by 3, 1. 6 divided by 3, 2. And so that takes care of simplifying the numbers a little bit. Next, we can work on the x's. Now you can remind yourself that x to the 5 means there are 1, 2, 3, 4, 5 x's all multiplied together. X to the 7, try and visualize it without writing it down. There are 1, 2, 3, 4, 5, 6, 7 x's along the bottom. 5 on the top, 7 along the bottom. So you can cancel out 5 of them, and 2 x's are going to be left, namely on the bottom. Okay. The rule This is a review question. So going to last day was also to subtract these. When terms are divided, you subtract the exponents. So 5 minus 7 is a minus 2. That'll be on the top. And you move it top to the bottom. It's still a 2, but it's positive now. Okay, so we still get this same term happening. For the y's, nothing. Y squared, that just stays there. Just like that. What's on the outside? A negative 3. What are we going to do? Flip now the inside upside down. Say that. Inside upside down. We're going to do that, and that'll get rid of the negative. Inside upside down, 2x squared. It's the bottom. The top is y squared. Now positive. All right. Now, I can see I'm going to run out of space, so I'm going to continue over here. Not really a fan of that. I like the answer, things going down. It's properly organized that way. But you can see it's going to be a struggle. So off to the side, we use the rule that each thing on the inside will now get this 3. The 2 gets the 3. The x squared gets the 3. And the y squared gets the 3. What happens? Well, for the number, you can just work it out. That's just 8. 2 times 2 times 2. Here, this exponent rule is super important, right? And with this situation, these exponents are always multiplied together. Super important because we're using that today. Right? 2 times 3 gives you 6. On the bottom, that's a 2. It's almost turning into a 7. All right, but notice the same situation. Exponent on the outside, one on the inside, bracket in between, multiplying. Y to the 6. Finished. All right. Next, back into fractions. Number 3. 5 over 2 is an improper fraction. And we want to switch it to a mixed number. Well, here's how you do it. What you go is, you go 5 divided by 2 is equal to what? Well, it's going to be 2.5. So that doesn't really help. So think of it maybe like this. 2 times what number? The bottom. 2 times what number gets you close to 5? Well, the number 2 does. 2 times 2 gets you 4. And then how much extra do you have to go? You know, you have to go 1 more. All right, so 5 divided by 2, it gives you a 2. And then, which gets you up to 4. And then there's 1 extra. And that 1 extra is written like this. 1 over 2. 5 divided by 2 gives you 2 with 1 extra. This number 2 is just that number right there. So maybe as a little side example, let's say you had 7 over 3. 8 over 3. How many 3's can go into 8? 2 of them. Well, that gets you up to 6. So how many more do you need? You need an extra 2. Okay, over the thing you're dividing by. Now, for the question number 3, that's it right there, not this detraction. That's interesting, but that answers your question number 3. For number 4, you're given a mixed number. So to get the improper fraction, this one's a little more orderly. You take the bottom times the big one, and then you add the top together. Okay, so you go 2 times 3, and then plus 1. And this is all going to be over the fraction part, the bottom part, the denominator, all over 2. Okay, don't go crossing those out. That's like going backwards. Don't want to do that. You actually want to work out what the top is now. Okay, so 2 times 3 is 6, plus 1 is 7. 2 times 3 is 6, plus 1 is 7. Denominator is 2. And so this now is 3/2 written as a improper fraction. Okay, so that finishes up the warm-up. Hopefully now you're ready and in a good situation to continue with the main part of the lesson. So I'm going to stop the video there and set it aside and get ready for the proper lesson. You're invited to do the same, and I will see you shortly.